Section 4.9, Quadratic Systems. What we're going to do is solving systems of linear and quadratic equations. So sometimes you're going to have a quadratic equation and a linear equation. You have to solve them together. Sometimes you'll have two quadratic equations. How do you solve those together? So we're going to look at just a few different things. And solving systems of quadratic inequalities. I can't remember if we're going to do that or not. We'll see when we get there. Solutions of a linear quadratic system can be no solutions, one solution, or two solutions, kind of like we looked at before. It kind of depends on what you have. So let's look at a couple and then you'll figure that part out. Here's problem 2. What's the solution of this system? Notice the first one is a quadratic. That would be a parabola. So kind of think in your head when you see quadratic, immediately think parabola, because on the graph that's going to make a difference. If you have a line going through a parabola, you could have possibly two solutions, right? What if the line doesn't go through the parabola? Then you could have no solutions. What if the line hits, for instance, the vertex? Then you'd have one. So right now, we could possibly have two. We'll see what happens when we get that far. First thing that pops into your head probably is, since they're both equal to y, can we just substitute one in for the other? It's exactly what you're going to do. So I'm going to substitute this right here in for that y. So I'm going to put the x plus 3 on the left and the negative x squared minus x plus 6 on the right. Then it's just like solving a basic equation. You're going to put like terms together on the same side, see if you can factor it, see if you could maybe put it in the quadratic, what are we going to do from there? So these are actually a little bit easier than most. Since the x squared is negative on the right, I'm going to move it to the left. If I add x to the left, I get 2 of them. And then if I subtract 6 to the left, I get minus 3. Now, what do you think we should do with that? Should we factor it, put it in the quadratic, complete the square? What do you think? Do we know factors of negative 3 that add up to 2? Yeah. So do the absolute simplest thing that you can. Probably nobody is going to choose completing the square anymore. Only if it's required. So I would definitely check factoring first, but remember that quadratic works for everything. So if you're having like a brain dead moment that you're like, I don't even know what factors of this add up to that, put it in the quadratic, you'll still get the same answers. Okay, so unless they say factor, it won't matter. So either way is totally okay. So I'm going to go with x plus 3, x minus 1. So we have factors of negative 3, which means I need one of each sign. The middle number is positive, so the larger number gets the positive. And then we go and we solve each one. So for this one, x plus 3 equals 0. For the next one, x minus 1 equals 0. So x equals negative 3 and 1. But we want solutions, so we also need to know the y's that go with those. So now we're going to plug them in. So before, all we had to do was factor and get 2 numbers. Now, since there's y's involved, we do need to know what those are as well. So I'm going to plug it into the simplest equation possible. It shouldn't matter, though, but I always pick the one that looks easier to me. So y equals negative 3 plus 3. That would be a y equals 0. And then put it in an ordered pair. So the first one would be negative 3, 0. I'm going to plug a 1 in there as well. So y equals 1 plus 3, y equals 4, and then it would be 1, 4. X goes first, y goes second. You don't have to show that substitution in if it's a really basic equation. Even if it isn't, as long as you do the y, it doesn't really matter if you show that part, because you can just type these in your calculator too. Okay, they're the answers that we had. I'm using those and plugging them in this equation right here. So it wouldn't be. Oh, I see now. Okay. So we're just substituting? Okay, you're seeing it? Okay. So the solutions here, so this is a parabola and a line, and the line actually hits it twice, which makes sense. Okay. Now we're going to skip that one for now. Here's another one. This one is parabolas for both. So then you think, well, maybe this could be 1, maybe this might be none, maybe this could be 2. So again, depending on where the parabolas are, in the first one, that one is a parabola opening down. In the second one, it's a parabola opening up. So we could actually have 2. So keep that in mind when you're picturing these things, that you could have 2, but maybe you don't. It just depends on where they fit. It's still a substitution question because we're going to substitute this part in there. So we're going to have kind of a lengthy equation until we put like terms together. So on the left, x squared plus 7x plus 12. On the right side, negative x squared minus x plus 12. And then we will bring them to whatever side you want. I'm going to bring them to the left because then my x squareds will be positive over there. So I'm going to add x squared to both sides. I'm going to add x to both sides. And I'm going to subtract 12 from both sides. So when you subtract 12, the 12s actually cancel. Now, this is the one that many people kind of struggled with. God, I don't like it when there's 2 things. I don't know what to do. Again, you can use the quadratic, but what part is missing? It's like the C part, and what do you put in there if it's missing? 0. So if you're struggling with factoring this thing, do A is 2, B is 8, C is 0. You should get the same answers either way. I like to factor them because I do think that they're faster. So I'm going to take out as much as I can, which is a 2x. If I take 2x squared and I divide by 2x, I have one of the x's left. Basically, you're subtracting the exponents on the x's and dividing the numbers. So if I take 8x and I take a 2x out, I take 8 divided by 2, that would be a 4. And if I had an x and I took it out, I don't have anything left. You'd subtract those exponents there also. Set each part equal to 0. So here x equals 0 and x equals negative 4. So then we plug them in. So here, it doesn't really matter which equation you pick. They're both kind of the same level of complicated, I guess. So I'm going to choose the second one because it's positive. So when I use x equals 0, it is going to be y equals 0 plus 0 plus 12. So I'm plugging a 0 in for both those x's. So I get y equals 12. Ordered pair 0, 12. The parabolas, you're probably going to get some crazier numbers as far as bigger numbers, just because of the squareds. Then I also have to plug in a negative 4. So that would be 16 minus 28 plus 12. That is 0. And you certainly could plug both those points in, like the x part and the y part, to see if they both work. Then you would know for sure if you got them. So if you did that, you would go, if I chose the second one, I'd plug a 12 in on the left side. 0, 0, or 0 plus 0 plus 12 is 12. So it should work. You shouldn't have to move anything, on sides. It would just be checking to see if the numbers work. So when it's squared, you could have 2. If more things cancel, you might just have 1. If everything cancels, then you wouldn't have none. So it kind of is something that you have to just think about. What if you had something that when you plugged it in, everything on the right canceled with everything on the left? That just means there isn't any answers. It's weird, but there isn't any answers. So if you actually had a graphing calculator right next to you and you typed it in, it would be 2 parabolas that are just sitting there. They wouldn't cross at all. That's kind of what it means. Okay, now I'm going to look to see if I assigned these. I don't know that I did.